things which are non-zero at different times. And the algorithm has an exponential runtime instead of some polynomial runtime. But if you don't do that, then you don't actually get the right solution. Now that doesn't really happen in practice. And in most cases, it doesn't make a very big difference, but you actually want to kind of, if they cross zero again, you want to set them to zero. That's the actual right way to do it.
So do you get the coefficient negative because of the outlier terms? Because of the outlier terms?
No, the coefficient, oh, you mean this coefficient
yes.
is describing this. Yeah, so what happens is that, so remember when I said that one of the uses is that it's easy to interpret. This gives you these explanatory variables. So what can happen is you can have, if you're just going to use one variable to explain something, you may choose something like the household income. But if you want a denser solution, then maybe you want the husband's income and the wife's income. And now both the information described by these two variables essentially tells you the household income. You can kind of add them together and get the household income. So then you don't need the household income coefficient anymore. So you want to set this back to zero. Right? So as you want a denser solution, sometimes you want to kind of switch from using one variable to two other variables to give it a better explanation. So there's not like, this gets back to the solution you get is not the only way to explain it with the small number of variables. That happened to be slightly the best explanation. In order to draw a picture, you need to get to higher dimensions, because I think you need to play with at least 3 dimensions to see it. But you can kind of, the solution starts out here, and it hits on this point, and then later you want it to be on the corner of kind of on the ridge between the y and the z variable. Where initially this one's closer, but then it becomes closer to both of these together. And if you think in 3D, you can kind of see this happen, right? But then this one would be 0 bit. So then the data point would be like the least square solution would be out here. So it's a little bit hard to kind of conceptualize, but if you look in this Elements of Statistical Learning book, they have different ways of visualizing them where they kind of plot the coefficients as you increase beta, and you see them going up and down. It's kind of an explanatory, and you see them getting back to 0, and they can kind of explain this a bit better. But it's still, you kind of have to trust that it's there, or maybe work through some careful but complicated examples.
So is the lasso the same as least angle regression?
Least angle regression is an algorithm to compute the lasso, right? And then there's the thing where you snap it to 0 is called something slightly different. I forget the name of that. But so the lasso is the optimization procedure for that. Just like the one with the 2 norm is the ridge regression or the Tikhonov regularization. But and the solution is just the kind of the matrix inverse. You could imagine something that just ran like gradient descent or something like that. You could also perhaps solve it that way. But this is kind of a more hardcore, like concrete algorithm. So okay, cool. So the homework is due on Wednesday, and I'll try and post the regression homework soon. It probably won't involve any of this beyond doing some very maybe some simple things with it, and we'll talk about noise starting on Wednesday.